Java class loaders are one of those hidden but essential parts of the Java runtime. They're responsible for loading your class files into memory and making them usable by the JVM. If you've ever run a Java application, you've already relied on class loaders even if you didn't know it. When you run a Java program, the JVM doesn't immediately know about all the classes your code depends on. Instead, it uses class loaders to load them on demand. This process starts when a class is referenced for the first time. The class loader finds the corresponding class file, reads the bytecode, and brings it into the JVM's memory. Java uses a layered system of class loaders. At the very base, there's something called the Bootstrap class loader. This one is built into the JVM itself and is responsible for loading the core Java classes, like java.lang, string. Above that, there's the platform class loader, sometimes known as the extension class loader. It loads classes from the JDK's optional modules or libraries. And then there's the system class loader, also called the application class loader, which handles the classes in your applications. Class path. What's interesting about Java class loading is the parent delegation model. This means each class loader, when asked to load a class, first delegates the request to its parent. Only if the parent can't find the class does the current loader try to load it. This avoids class duplication and maintains security and consistency in the runtime. Java also allows you to create your own custom class loaders. This is powerful if you want to load classes dynamically, isolate plugins, or create secure loading environments. You simply extend the class loader class and override the find class method. This approach is often used in frameworks, plugin systems, and application servers like Tomcat. Class loaders can be tricky to work with, especially in large applications. They're often involved in some of the hardest to diagnose bugs in Java. For example, you might run into a class not found extenty when the class loader simply can't locate a class file. Or you might see a class defounder, which usually means a class was available at compile time but missing at runtime. One of the trickiest problems is a ClassCastException caused by loading the same class with two different class loaders, even if the class names match. The JVM considers them totally different types because they came from different loaders. Understanding class loaders becomes especially important when you work with frameworks like Spring or Hibernate. These frameworks use class loading tricks to create proxies, inject dependencies, and manage complex runtime behavior. In web containers like Tomcat, each application is given its own class loader to avoid conflicts between libraries. Starting with Java 9, things got even more interesting with the introduction of the Java Platform Module System. Now, modules and class loaders work together to provide more control over which parts of your application can see and use each other. If you're trying to debug class loading issues, there are a few tricks. You can print the class loader for any class using myclass.class.getClassLoader. You can also launch your application with the verbose class flag to trace which classes are being loaded and from where. And for deeper analysis, tools like JVM or Java Flight Recorder can help you visualize class loading behavior. In the end, class loaders are part of what makes the JVM so flexible and powerful. They enable dynamic behavior, modular architecture, and runtime flexibility. If you're serious about Java development, especially in backend systems or frameworks, understanding class loaders is not just useful, it's essential. Thanks for watching. And don't forget to subscribe for more deep dives into Java internals and backend engineering.